Hello everyone, and welcome to the first webinar organized by Bardiani Valvole. Bardiani Valvole is an Italian company born in 1981, specialized in design, manufacturing, and trade of hygienic valves. I am Viviane Costella. I am sales director and working in Bardiani since 1996. Before entering the today's topic, which is about safety in industrial processes and how to prevent the risk of fluid cross-contamination by the use of mixproof bags, we want to say thank you. We are so delighted that you are so many from everywhere in the world who have decided to attend this webinar. So thank you very much, really. Very shortly, I will pass over on my colleague, engineer Luca Ollari, who is co-responsible of R&D unit in Bardiani and a member of the EHEDG working group. And I would like to say some details about this webinar. You will have the possibility, of course, to ask questions, and we will try to answer all of them. If it's not directly today, we will do it very shortly by mail personally. This webinar is also recorded, so you will receive the link for it. So now it's with great pleasure that I pass it on my colleague, engineer Luca Ollari. I wish you all a good listening. Luca.
Welcome to everybody. Thanks, Viviane, for the introduction. Today we will focus on a very important topic in a food process, safety. Safety in preventing contamination, safety in properly cleaning all the parts in contact with the product, and safety to avoid not mixing with incompatible product. We will therefore analyze the evolution of the valve component in the industrial process. We will talk more deeply about mixproof valve and the working principle. And we will take a look of the certification for the design and for the hygienic design principle. And then we will tell why we need to use a certified mixproof valve. At the end of the presentation, we are able to answer to your question, if you have, and to give you some answer. So starting with the beginning, first of all, let's start with what happened in a plant. So basically in a plant, we have a movement of fluid from the tank to the filler. We move the fluid due to the pump through the line and through the different kind of component. These pipelines are separated from each other. And when we need to put together one of these two lines in this junction zone, we need to manage this safety. So the general idea for food safety in industrial plant is to keep the line separate, to avoid contamination, and to keep mixing phase under control. It's very, very important. So how we ensure safety in food plant? The way this typically happen, mainly because it's the most economical solution, but as we will see, less hygienic and more wasteful, is certainly through the use of the swing panel or flow plate, depending how do you know it. In this plate, the operator use a band to connect the different line based obviously on the process. So it's a manual change of the line. So this the main problem in safety with this kind of application is that everything is rely on the manual action of the operator, who physically change the connection on the panel according to the instruction that usually are on the panel. And in doing this, the operator must obviously pay attention to not exchange or to not put in communication, for example, the CIP line with the product line. So not to mention also the product losses that occur in this type of application during the band change. Typically, you can notice in the lower part of the panel, the drip tray for the waste, underneath the panel for these losses. So obviously, entrusting this kind of operation to a single operator who has to make all this change manually can, in a long run, cause some problem from a safety, from an hygienic point of view. So from a plant manufacturer point of view, the next step was the use of the butterfly valve, a sort of small group of valve, butterfly, like in this picture. You can see here we have 3 butterfly valve. These are called block and bleed combination. So you need 2 valves that block the line. So you have one line here and the other line here. So these 2 valves are closed to block the product, and another valve that is bleed valve that you are open to the atmosphere. So if there is a leakage from one of the 2 valves, the product goes out directly from the discharge valve. And if you need to exchange from one line to the other, you need to close the bleed valve and open the 2 block valve. The next step was the substitution of the butterfly valve with a single seat valve. In the single seat block, you need only 2 of these. So basically it's a divert single seat valve and a standard single seat valve with the same function. So you have also here 2 block with the upper valve body of the single seat valve, and the lower valve body of the divert valve, you have the bleed valve. So you are able to immediately see the leakage from one of the 2 lines. And as in the butterfly, when you need to exchange from one line to the other, you exchange divert the single seat, and you can transfer the product from one line to the other. Obviously, if you put together this valve and compare it to a Mixproof, the Mixproof valve, it's only one unique valve. So you have a reduction of space and a reduction of control that you need on the plant, and also you reduce that area, that zone that are difficult to clean in these block and bleed parts. So if we wanted to schematize and represent on a diagram the relationship between the safety, flexibility, cleanability, and the reduction of the product losses, and also to increase of productivity, we have a diagram similar to this one. So in the bottom part on the left, you have the flow panel, because it's the part that with less flexibility, less safety, and less cleanability. And then you go up and improve with the butterfly block and bleed, with a single seat block and bleed, and obviously with the last one, the Mixproof. So the advantage of the Mixproof are that the reduced number of valves. You need only one to make all the operation that you need to do with 3 or 2 valves, depending of what you choose. And obviously the space reduction. So the cluster it's smaller compared the length of the pipe is smaller compared to the old solution. and less valves also to manage and to maintenance. So it's quicker to make maintenance because you have less valve on the plant. So up to now, we have seen the reason that have led plant engineer to transition from using the swing plate to using the mixproof valve. As you can see in the picture here, for example, you have a small cluster of mixproof valve, and all these phases you can do it at the same time. So you can fill a tank, empty a tank, cleaning a line, empty another tank with the product. All this operation work at the same time due to the mixproof valve. Now we will go into the detail of this component and the operation in the various phases of the process. As we already mentioned, the philosophy of the mixproof valve is based on three fundamental principles: safety separation of the line, avoid cross-contamination, and in case we need to connect two lines with each other, like in this cluster, having control over the mixing phase. It's very important. So just a quick look of the structure of the mixproof. So in general, the mixproof valve consists of two chambers, the upper and the lower one, where there is two independent shutter, the upper shutter and the lower shutter. And between these two shutters, we have the leakage chamber, the space between them. And when one of the gasket from into the shutter leak, the product goes out directly from the valve through the lower shutter. So this is why the mixproof are safety compared to the other solution. And due to that, also a less experienced operator can realize quickly that something is wrong in the valve when he sees the leakage, and he can immediately operate. So now I'll show you a short video to explain the different phases of the valve during the process. So we're starting from the closed position because the closed position is the safety position. And if you don't operate into the actuator, so if you don't put air into the actuator, or if you don't put power in the solenoid valve inside the control unit, the mixproof valve, it's always closed. It's in closed position because it is the safety position. So we can start. So we have the two products, one in the top and one in the bottom. For example, now we can have milk on the top and the CIP in the bottom line, and we can make the lower lift. So the lower lift is a small movement of the lower shutter to be able to clean properly the leakage chamber when you have the CIP in the lower line. So you clean everything with some lift, and you discharge all the product outside of the valve due to the lower shutter. And the same things you can do on the other side. If you have the CIP, if you have the CIP in the top line, you can clean also with the upper lift the leakage chamber and discharge everything from the lower shutter. And the last, if you need to exchange from one line to the other, you open completely the valve. So you put air into the actuator, and the lower shutter push up the upper shutter. You can exchange from one line to the other. So why use a certified mixproof valve? So since we will see right now that using a Mixproof, it's a safety solution because you are able to keep separated the fluid without contamination. It's the quickness solution because it's very easy to dismount a Mixproof because it's only one valve, so you dismount a clamp and you remove completely actuator and the shutter from the line, and the automation, so you don't have any manual operation to do. Everything is automatic. So, but this is not enough to use to be completely safe on a food process. What you need is to not only comply with the mandatory rules of the current legislation, but also by obtaining the main product certification required by the market. Two of them are basically the 3A certification and the EHEDG certification. The 3A and EHEDG are both organizations that define the standard for hygienic design, particularly for the component in the food processing equipment, such as for valves, but also for pumps, for heat exchanger, and so on. 3A is the American organization, was established in the early last century, initially focused on the dairy industry. And on the other hand, EHEDG is a European association founded around 1990, and both organizations set rules and guidelines for the hygienic design of various components in the food process equipment, including obviously the valves. However, the main difference between the two certifications is that EHEDG requires a practical cleanability test to obtain certification. So you not only need to fulfill the rules, the standard, the guideline to make the design of the part in contact with the product, but also you need also to pass a cleanability test. So you need to demonstrate that your valves are cleanable, like a pipe. So I briefly explain this and the test involved in the EHEDG certification, just to give you a rough idea. First of all, you will take the third part laboratory, will take the valve and the reference pipe, a straight reference pipe. They clean it, both equipment, and they sterilize. Then they fulfill with solid milk, that it's full of bacteria, obviously. Then they pressurize and move a couple of times. Then they drain everything, and they put on a circuit, like in the picture in the bottom right part of the slide, and made a standard CIP, rinsing with the water, then cleaning with the valve with detergent, and then rinsing with water again. After these CIP phases, the valve is filled with a agar and incubated. The agar is a sort of gelatinous substance used as a culture medium for a bacteria, if there is still bacteria in the valve, because if the design is correct during the standard CIP, you will remove all the bacteria inside the valve, inside the valve body. So the agar help the bacteria to proliferate more faster if the bacteria is present again inside the valve. After these phases, the agar is removed from the valve and from the reference pipe, and we will see, like in this picture, the color. We compare the color of the agar in the valve and in the reference pipe. If the color is the same, and if it remain purple, it means that the valve is cleanable like a straight pipe, and so you pass the test. If the color is different and it turn from purple to yellow, for example, it means that there is still bacteria inside the valve, and the test is failed, and you need to redesign and to identify the problem in the design of your valves. And so you need to remake everything again until until the color of the agar in your valve is the same the color of in the reference pipe. And regarding this design criteria, the principle and the purpose for which this guideline were created, we thought that it would be appropriate to listen the opinion of an expert in this field. And so therefore we now hear from Professor Giampaolo Betta from the Parma University, president of the EHEDG Italy, and also a trainer for the EHEDG. And unfortunately, he couldn't be here online with us due to a prior work commitment, but he deemed it's important to leave us this speech and comments.
Afternoon, depending on where you are now. So first of all, thank you very much to the organizer for inviting me to this event. It's always very important to show and to increase the awareness regarding the hygienic design. So I'm really happy to be here and to represent this important organization that is the European Hygienic Engineering and Design Group. So I just would like to give you a very brief introduction on this topic, and then the next speaker will go in deeper details, deeper technical details. So first of all, what is hygienic design and what is the role of hygienic design in our legislation? In the European legislation, at least, hygienic design is something compulsory. And it is compulsory according to our hygienic package regulation. And hygienic design is seen as a prerequisite by the European law. That means that it must be applied before any further risk analysis or ACCP procedure. So it is not an option. It is not something you can choose to have or not have. It's something compulsory for every equipment used in food processing. Then, where should we apply the hygienic design? We can benefit from the hygienic design in the whole food chain. So from farm to fork, so starting from the primary production up to the consumers. So every step can be, can benefit from hygienic design. At what level can we apply the hygienic design? If we look inside a food factory, we see, first of all, a building or an area around the building, then a building, then internal areas, production areas, then production lines, plants, machines, components, up to every single part. And we must apply hygienic design to every different level. So we must apply hygienic design to the layout design of the food factory itself, so including the external area, to the building, to the production areas inside the building, to the production lines, to the machines, to the plants, to the single components, up to the individual parts. So, and of course, behind every of these levels, there is a production chain. So behind every single part, individual part, there is a supply chain, there is a production process. So there is a material selection, there is a selection of the manufacturing operation needed, such as casting or machining or whatever. There are assembling operations, there are integration and installation operations. And in the end, we use these plants, we use these buildings, we use these parts. And to do that, we usually need utilities, and we usually need some product and procedure to clean them. And we need maintenance, so we need also procedures, people, products for maintenance. For example, we need lubricants. And every step, every component, I mean, every procedure need to be considered as a potential source of risk for the consumer. So hygienic design must be considered at every step of this process. So when we talk about risks in the food sector, we refer to three big categories of hazards called physical hazards, chemical hazards, and biological hazards. And you can see here some examples. So in the case of physical hazard, we have in mind mainly, undesired objects, so such as part of a machine, part of material of packaging material, so something that may harm the consumer, for example, while biting something. Chemical hazards come from various sources, so they can come from the environment, for example, because there are some other industrial activities in the surrounding areas, or they can come from our process because we use this chemical, such as in the case of lubricants, and they can cause several types of damages to the consumers. So they must be taken in particular consideration, and we should also consider allergens as possible chemical hazards. I mean, they are substances dangerous for a limited number of people, but they can be very seriously affecting the health of those people. So they should be considered very carefully. And then biological hazards, we mainly talk about microorganisms, so organisms, living organisms in the size of a micron. So very small, not possible to be seen by naked eye. They grow and multiply very fast. They can adapt to various conditions very fast. They are in the product naturally because they are everywhere. They are in the soil, they are in the air, they are on our skin, so they are everywhere. So they are really, really tricky enemy for food safety, and the food industry need to control them, and it is really a demanding challenge. So what to do, what we do to control these hazards, and mainly what we do to control biological hazards. Essentially we clean, and of course cleaning sufficient to control all hazards, but usually it is a necessary component to control all hazards. So essentially we need to create good conditions so hygienic condition for food production. And these conditions are affected by the food process itself. So in the time, along the production time, the conditions get worse, and so we need to restore these conditions. And that's why we use this cycle. We clean, maybe we disinfect, and so we have again this good condition for food production. So, of course, when we decide that we need to clean, this means that we must be aware that we need something cleanable, because we don't just like to clean. We want that the building, we want that the plant, the machine, the component is cleaned after the cleaning process. So it's something, yeah, quite a lot different. So we clean, and we want that cleaning is effective. And to get that, we need cleanable equipment. We need cleanable facilities. Then I like to show you this quite important difference between two big families of processes, open and closed processes. And in the next speech, you will get in deep details regarding the closed processes, I guess, where we have a big advantage because we know quite well the cleaning technique used, because closed processes are normally cleaned using an automatic cleaning technique called cleaning in place. And this technique is basically a flow of a cleaning fluid inside the circuit. So we know that we need a certain flow rate. So I mean, this technique is quite well defined. So we know what we do. And in the open processes is not exactly the same, because the so-called open plant cleaning is a combination of many different techniques. So we don't know exactly in every process and what happens every day. There is a lot of human labor, so it is something a little bit more challenging from this point of view. But closed processing, we know very well what we do, and this is our starting point. So considering that we know what we do, we can really define clearly what we need in terms of hygienic design. And for example, I just want to give you a couple of very basic examples. For example, we know that TPs are not cleanable, are not enough cleanable in a closed system. Yeah, most of the time when we need to install a sensor or maybe a valve, we can assemble, we can make a connection using a TPs. It is the easiest way probably, but it is not an hygienic way. It is not cleanable enough. And there are available on the market other solutions with a flush mounting of the sensor or whatever in the pipeline. So we really need to make a choice and be aware of the consequences of the choice. If we use a TPs, we will probably need very long time to clean it, and maybe even with long time we cannot clean it completely. So it's very important to be aware of it. Of course, this example was a very basic example. So we know that in complex machine, we have very complex component, very challenging features where it is very difficult to have a so clean design, so basic and clear and easy cleanable design. So in these cases, we really need an optimized combination of the best design possible in terms of smooth surface, no angles, etc. So something that improves the cleanability, so the possibility to clean it, together with the best flow dynamics possible. So the best design to have the highest mechanical action in those parts more difficult to be cleaned. So the design gets more and more difficult, tricky, and needs support from a lot of different sources. Maybe computational fluid dynamics may help. And in the end, in these cases, we also need an experimental demonstration. And that's why we used some tests to demonstrate that particular feature is enough cleanable. So that's really all. I just wanted to show you the basics, and then you will go in more details regarding the valves with the next speakers. I just want to use less than 1 minute to promote this important event we have with EHEDG in October. It is our World Congress where we present this requirement, we present our philosophy, we present where we are today, and also we present the news. So we present what we want to do in the next future. So it's very interesting if you are keen on this kind of topics. So again, thank you very much to the organizers, and good. I hope that the next speaker will be interesting for you. Again, thank you and goodbye.
Thank Professor Betta for this overview on the fundamental importance of the hygienic design to enhance the food safety in industrial process. So, linking back to what we just expressed, you might be wondering what is the advantage of using an EHEDG certified mixproof valve. We will see the importance of using a mixproof valve in a food plant, but what is the difference between a standard mixproof valve and a certified mixproof valve? Over the year, mixproof have also undergone a significant development to meet the ever-increasing demand for safety, for efficiency, for cleanability, and for flexibility in industrial process. Here are some key features of the mixproof valve, certified mixproof valve. First of all, the advanced hygienic design, but not only from a theoretical point of view, but also from a practical point of view. So with the EHEDG certification, we are able to demonstrate that we are able to properly clean all the parts in contact with the product. And the high quality material, mixproof valves are made of high quality material that offer resistance not only to the corrosion, but also to the pressure and to the temperature. And we have automation and advanced control. The mixproof are equipped with the advanced automation and the control system that allow greater process control and flexibility. We increase the safety because the mixproof are designed to improve safety. For example, with the balance shutter to avoid if there is a water hammer into the line, to avoid mixing the product from one line or to the other. And also we have a regulatory compliance. So not only with the stringent safety standard and requirement in the industrial sector, but also this include the compliance with the design certification, like we will see 3A and the EHEDG certified. And the energy efficiency. So mixproof valves are designed to maximize the energy efficiency in industrial process to minimize the cleaning solution consumption and to optimize the fluid flow. This help to reduce operational cost and especially in this period, the environment impact. So how Bardiani get this certificate, this kind of certification? We obtain this by redesign the mixproof valve. We eliminate the dead area and the potential stagnation points inside the valve body. We improve the drainability. We eliminate the recess point, especially near the gasket. Especially in this area, for example, this is an old design of a mixproof valve. This is the new design. And also we control the deformation of the static seal to allow proper sealing. In this case, there is no recess point, and so during the cleaning process, we are able to eliminate all the bacteria, all the product on the surface. And finally, also we optimize the flow inside the valve body. This not only to reduce the pressure drop, but also to achieve the correct mechanical force. So we improve the cleanability of the valve to create the correct turbulence inside the valve body. And so now we are able to remove correctly the product during the cleaning phase. So this was a very important phases in design of the inner part of the valve body. So why choose a Bardiani mixproof valve? Not only because we have all kind of certification, so we have the 3A certification, we have the EHEDG certification, but also our valves, it's already full option. What does it mean? It means that we go on the market with both balance shutter already, so to avoid any kind of problem if you have a water hammer in the pipe, and also with the lift, the both lift, the lower lift and the upper lift. We produce all the part in contact with the product from a solid bar of stainless steel, so every part. And this material, this bar are coming from Europe, only from Europe, and are manufactured here directly in our plant in Italy. And due to that we start from a solid bar, there is an availability of using a special stainless steel material for very corrosive process and something like that. And also due to that, it's very easy for us to customize the valve on customer request. So we are able to make every change, every modification that the customer need in their process. And we have a wide dimensional range from the smallest one, the DN15, to the biggest one, the N150. And we have also the possibility to have a different dimension in the upper line and in the bottom line. For example, you can have the N100 in the top line and the N50 in the lower line without any problem, because we redesign everything to be able to also to have the same function, the same cleanability that the standard line. And also very important is the easy maintenance of our valves. easy maintenance because you don't need any kind of special tool to dismount the valve, to change the gasket, and also it's very easy because it's faster to make maintenance in the Bardiani Mixproof valve compared also to the other. And last, the original part dispatch guarantee in 48 hours, the original part. I point this because when we achieve the EHEDG certification, we not only certify the cleanability of the valve, we also certify the compound, the material of the gasket and of the plastic that we use in contact with the product. So only using original part, you are able to have a very long lifetime of the valve. And for this is finished my presentation, so I'm open to answer. I pass the word to my colleague Viviana Costella. We are open to answer to your question in this time.
Thank you, Luca. Thanks a lot for your presentation. Yes, we have some questions and we have some time left, so we will start immediately. Do you have different types of Mixproof valves? Yes, this has come from different attendees.
Yes. We have this presentation is focused only on the standard basic Mixproof valve that are used on a cluster. But we have the complete range of Mixproof valve from the bottom tank Mixproof, or from the aseptic Mixproof, from the piggable Mixproof valve, the double seal, double seat Mixproof. So we have the complete range of Mixproof.
Okay. Can you manufacture the parts in touch with the product as a long material?
Yes. As I already said, we can we start from a solid bar. We can produce in different kind of stainless steel material, in a alloy, in a SAP, and other duplex or super duplex material.
Okay, there is a question about the unique selling point of Bardiani compared to Betta or Valvole, Kieselman. I think we could say that there is a table that we have studied and analyzed. Maybe we could supply directly by mail, personally for us, right? Okay. Any other questions do we see? Sorry for that. The different types, yes. Where we can find a list of certified valves from all manufacturers.
Okay, and you can find the list of certified equipment on the EHEDG internet site, on the 3A internet site, and be sure to check on the internet site of the 3A of EHEDG, because it's very important, because there is a lot of competitors that use improperly the EHEDG mark, the EHEDG logo, because they put in accordance to EHEDG, but it doesn't mean they pass the test. It means they design probably the valve in accordance to the guideline of EHEDG, but they didn't perform the test. So it's very different, because if it's like if you take a drive license only on theory without the practice. So it's very important to check the component on the EHEDG site that are certified, because there is a lot of difference between the certified equipment and the not certified equipment, but only in accordance to the EHEDG.
Okay, now the very last question. Unfortunately, we don't have much time left. Do you offer piggable Mixproof valves?
Yes. We have a complete range of piggable valve, from the single seat to the double seal Mixproof valve.
Okay, Luca, well, time is over now, so we say again, all of us in Bardiani, thank you very much for attending. We will organize other webinars, and we will keep you informed about the agenda of them, of course. So really, really, thank you very much to all of you. Thank you, yes. If you want to say something, Luca. Okay.
Thank you so much to everybody, and see you soon.
And see you soon, okay? We'll keep in touch, certainly. Okay, ciao, ciao.